Okay, so let's discuss some problems. See, the first problem, a particle of mass m located in unidimensional potential field, that means a conservative force field where U depends on U is potential energy, U equal to U naught 1 minus cosine AX, U naught and A are constants. Okay, find the time period of such oscillations. So here U is given by this function and X is very small obviously. So you know the force on the particle, as you know, the relation between force and potential energy is F equal to minus du by dx. That means if you differentiate this expression minus, so get what, minus u naught a sine of ax. Okay, now if x is small, then sine of ax is approximately equal to ax. Therefore, f equal to minus u naught a multiplied by ax, so u naught a square x. So that is the time, this is that minus kx, that is, therefore mass m d2x dt2 is minus u naught square by a square, if this mass is brought here, by m into x. So the angular frequency omega is equal to u naught a naught by root over of m. So time period is 2 pi by omega, that is 2 pi root m by u naught a naught. Okay. Let's go to the second problem. Here it is given, find the time period of oscillation of mercury of mass m poured in the tube, in the U tube. Both the arms have same cross section A. See, it's given here. Cross section of each arm is equal to A in both cases. Now, solution. Say, let's look at this case 1. Now, case 1. See, say this was the level at start. Now the liquid goes down by a small distance x. So as the volume is conserved, here also liquid goes up by the same distance x. Now we will calculate the excess force. What is the excess force on the liquid column? As you see, if you draw a level here, say on this part of the liquid, the excess force is due to weight of this much liquid, right? So the excess force equal to F is magnitude of the force is equal to due to weight of this part. So it has length 2x a rho g. Now therefore, now if you insert the sign, then F equal to minus 2a rho g multiplied by x. So therefore the time period of oscillation is 2 pi root over of mass by this is the k, 2a rho g. Okay, let's go to the second problem, that second case where one of the arms of the tube is tilted. See here, so this was the initial level of liquid. Now if this goes down by a small distance x, this will go up by that same distance x, and this is theta. Okay, so let us draw the level here. So there is force due to pressure applied by this much column of the liquid. So how much column of the liquid is there? Which creates the excess force? How much column of the liquid is there? as you see, this much. So this excess force, if you put a minus sign, minus of this x plus x sine theta height rho g into a, right? This much force acts in this direction, right? Now if you see the area, then it is not really a, it is a divided by cos of theta, right? So each act, so the excess force actually acts on this much area, right? So it acts in this way also, but we need the component parallel to the arm. So this extra force, we need this force, this is F. This force will come out to be this. So therefore my F equal to minus of, let's see, A rho g 1 plus sine theta multiplied by x. So we get the time period of 2 pi to our total mass by A rho g into 1 plus sine of theta. Let's move on to the next problem. See here, two particles undergo SHM of same time period t, amplitude a, about same mean position at time t equal to 0, while one particle is at the mean position, other is at the extreme. Find the maximum distance between particles, and the maximum distance occurs for the first time at, that means this is I will draw in this way. This is the motion. While one particle is here at the mean position, the second particle is at the extreme position. Here, see, this particle is here, while other particle is here. Okay, so this particle here, obviously it is going towards this position. Now let's draw the reference circle that helps in problem solving in these cases a lot. As you see, as they oscillate about the same mean position, amplitude also same with the same frequency. Now this particle and this green particle, reference, the circular motion, this green particle is shadow of this particle, is going on, while this red particle is moving like this. Okay. Both have amplitude A. Now what has been asked? Find the maximum distance between the particles. Now the maximum distance between the particles occurs what? See, these are the particles in circular motion. We have been asked to calculate maximum distance between these two particles. These two are shadows of these two. This is just for reference. So I can say that the maximum distance between the particles occurs when this particle moves here, while this green particle moves here. And by the way, we know one thing, that the phase difference between these two particles is 90 degree, and that will stay same as 90 degree because the angular speeds are same. So this particle and this is for this particle. Okay, so as you see, the maximum distance both having amplitude A, so this is the maximum distance between the particles. Now here this shadow will come here going down, and this shadow will come here going down. This is the maximum distance. So what is its value? It's root 2a. So we can write maximum distance between particles is root 2 times a, and also it has been asked to find out the time. I think the time, find the maximum distance, find, and the maximum distance occurs for the first time at. So if you consider this particle, this has to move how much distance? See, obviously, see, it moves how much angle? 90 degree plus, that is 45 degree. So that is 90 degree plus 45 degrees. So each particle has to move an angle of 90 plus 45, 135 degree. Therefore the required time, this particle, this was a situation as at time t equal to 0. Now this moves on to this position, required time t equal to, okay, so that should be t divided by 360 multiplied by 135, this many seconds. I hope it's clear.